Hey students, Mr. Clausen here. Just wanted to go through a state of matter lab with you. We are going to be taking a look at mixing cold water and some hot water. The hot water I just got here out of my tea kettle. And so I'm pouring that in. It is fresh, so hopefully it'll be around 100 degrees. And then for equipment here, and I'll show you how this works, I have this digital thermometer that is hooked up and it is streaming to my iPad. And I'll put that up on the video screen somewhere so you can see it as well. I'll do that right now. And so if we take a look here in the cold water, we can see that the temperature is around 5 degrees, right? 4.9 degrees Celsius, and that's good. This isn't quite freezing water, it's just ice water, so it's not gonna be zero perfectly, but you know, that's a pretty good measure of where we're at. Okay, so when I mix it just up a little bit more, that's a little better. We get about 4 degrees, which is good. And now let's take a look at the hot water. And if we put that in, we can see that that's going up quite rapidly, and we're gonna be looking for something in the 90s to see if our thermometer is properly calibrated. This isn't pure water, this is tap water from my house. And the other thing is, you know, it's not boiling right now. It was just boiling a little bit ago. And so as it sits here, you know, it's going to cool off just a little bit. All right, so let's give that a little swirl. Maybe it cooled off more than I thought it did. But anyway, we'll let that sit there and reach its temperature. So we're at about 89.6 right now. So definitely hot between the two. Now, looking at your lab report, let's go through that. There's some pre-lab questions that you need to fill out. Your hypothesis, you should write as an if-then statement. Basically, what we're going to be doing is we're going to be taking the cold water, equal amounts of cold water and hot water, and mixing them here in a third container. So you're going to need to then identify what is our independent variable, our dependent variables, and then what are the controlled variables. And I'm not going to say that for you. That's for you to figure out. I'm just here to do the procedure with you. Now, we have hot water, we have cold water, we have a thermometer, and we have a measuring cup. The one thing is it said to use foam cups, and I didn't have any foam cups, and I thought it would be better if I used these glass ones so you can actually see what's going on. The only difference is they are going to you know, not be as well insulated as, say, some of the other ones were. So it says to measure 50 milliliters of hot water and cold water and put them into separate cups, which we did, and measure the temperature, which we did, and then we're going to pour them into a third cup. We're going to predict what happens. All right, so that's the data part right here. So let's do the temperature of the hot water. So I'm looking right now. In this one, as it states, the temperature is 87.2 degrees. And then I think, if I remember right, the cold water was, it was like 4 or 5 degrees, if I remember right. So let's let that go in. The temperature is dropping. All that really means is the thermometer takes some time to actually reach equilibrium with the water as well. All right, so where are we at here? Just waiting. They're going to drop much more. No, that's right, 5.3 is the temperature there for it. Now, we don't need to put degrees Celsius on it because it's already circled there or in it. Now, the predicted temperature is something for you to fill out. I'm not going to say it. So you're going to say, what happens if we were to mix equal amounts of these? What would happen to the predicted temperature? And then what we'll do is we'll actually do it and see what it turns out to. Now, I did some conversions ahead of time. It turns out that 50 milliliters is pretty close to 1/4 of a cup. And so I have 1/4 of a cup measuring cup right here. And so all I'm going to do is, not with any ice, just get 1/4 of a cup or pretty close to 50 milliliters of cold water. And then I'm going to get 50 milliliters or 1/4 of a cup of hot water. We're going to mix the two together, and then we're just going to find out what the new temperature is. All right, so watching there, we're going to let it reach thermal equilibrium. That's a fancy way of just saying the balance point where everything has come to the same temperature. So we'll give a little stir there. And we're in the 34, 35. I saw it go up to 35 for a second, and then it dropped 34.5, go up, and then drop back down. So if I'm holding this, I'm thinking that's holding pretty steady at 34.5. So the final temperature was 34.5 degrees Celsius. Okay, now what we need to do is just do it again. Dump that one out. Let's get the temperature of the cold water first here. So I'm guessing it's going to be pretty close still to 5.3, but we'll just check, take a look. Okay, so the ice in there has actually given our cold water a little bit cooler temperature. It's at about 2.4, so some of that ice has been going. So let's write that down, 2.4. And then let's get the temperature here of the hot water. It's probably going to have cooled off. I don't know if it's showing up in the video, but I can see the steam rising, which means some of the energy is being left from the system. And it's glass, so it's not like the best insulator here. It's just a single wall glass. But let's find out. Let's give it a second for that thermometer to reach. All right, I'm gonna call it at 79.1. And then what we need to do is do the same thing. So 50 milliliters, cold. And then 50 milliliters of the new hot. So you'd make your predicted temperature. Let's see what this comes out to be. And I'm going to call it there at 35.4. You'll notice that when it touches the glass, we get a slightly different reading, and that's because it's actually measuring the temperature of the glass itself and not the liquid that's in it. All right, final one. Let's let the hot water kind of get our new temperature for that. And this time what I'm going to do is going to do a little bit different. Number one, I'm going to fish some of this ice out of here so that it stops getting so cold on us and we can stay closer to what that temperature was. And what I want to do is I want to add some food coloring to each container, and so you can kind of see the difference in how the particles are actually moving, which is kind of interesting if I take a look at it. So we got this one right here. The hot water is at 75, 75.5. Now let's try and get this a little closer to the camera so we can see. Let's call that good right there. So here's some red food coloring for hot, and what I'm going to try and do is add just a couple drops. Okay, and at the same time now, what I'm going to do, put a little white background there, is I'm going to do the same thing now for the cold water. And I want you to just notice if there's anything you notice about it. 1, 2. Okay, I need another white background here for you to see what's going on. There, one of my son's birthday cards. All right, so this stuff was mixed at basically the same time. I mean, I know the hot water's been sitting there a little bit longer than the cold, but what you notice right away here is that the cold water, while the blue is mixing in, it's not mixing in nearly as quickly or as evenly as it is in the red hot water. And the reason for this is in the hot water, the molecules are actually moving around a lot faster, and this creates like turbulence or mixing inside of it. And so what happens is when you add that food coloring, it's able to mix around much, much quicker. And it just shows that the particles are moving, or can help, it lines up with the idea that the particles are moving faster. Over here in the cold water, the particles aren't moving as fast. And so what happens is it takes longer for that food coloring to be mixed within the two containers evenly. All right, so we got that. Now, the food coloring isn't going to mess anything up too much for us here for the actual demo or for the actual lab. So let's get our hot water temp and we'll mix the two. And I should really have put the caps on the, what's this called? Food coloring. That's a mess if it ever spills. If you've ever done that, you probably already know. All right, so the hot water has cooled down this time now. We are sitting at about, let's say 71.2. Okay, and now let's take a look here at what the cold water is. dropping rapidly. Let's get our final temp. Let's give it just a little. We'll give it a little mix. All right, I'll call it at 3.6 because we pulled those ice cubes up. It had some time to actually warm up a little bit. Now what we need to do is 50 milliliters of each. I don't know, let's start with the hot this time. Okay, we'll put the thermometer in the middle there. So there's the hot. And the cold. Now we get a purple. Makes sense. And then we'll just give it a second for it to reach its thermal equilibrium. All right, and there we go. I'm gonna call it at 34.3 degrees, and that is the a final. So that's the lab for what we were gonna do here. We had the hot being mixed with the cold. You should be doing the predicted temperatures like it shows, let's see here, like right here, that's you to take care of. And then you also need to be filling out the post-lab review questions, all right? And then that's it. So if you have any questions, you know where to reach me, and I'll see you when I see you.